So when we talk about the square root function, we mean something that's in the form of f of x equals square root of x. That is, whatever we use for x, our function is going to do the square root of it. The domain of the square root function is going to be all non-negative real numbers. And by that, what I mean by domain is all the possible x values you can use. So the possible x values you can use for inputs are going to be non-negative real numbers. So for instance, let's say I want to find f of 1 and f of negative 2 in this function f of x equals square root of 2x minus 1. So for f of 1, what that means is I'm going to take the 1 and replace the x there with 1. So f of 1 would be the square root of 2 times 1 minus 1. Order of operation, we do the 2 times 1 first, so that's 2 minus 1, which is the square root of 1, or 1. So f of 1 is equal to 1. F of negative 2, oops, let's try that again. F of negative 2 is going to be the square root of 2 times negative 2 minus 1. And that's going to be the square root of minus 4 minus 1, the square root of negative 5. Now, remember, the domain is all the non-negative numbers. This is a negative number. And what that means is that this value here is not real. If we want to graph, like say, the square root of x, start with what makes the inside the radical, inside the square root. Start with that and where that is 0. And then pick larger numbers of x. So the square root of 0 is 0. It's a good place to stop, to start. And then if x is 1, y would be the square root of 1. If x is 2, y would be the square root of 2, which in your calculator is about 1.41. If x is 4, the square root of 4 is 2. If x is 6, the square root of 6 is approximately 2.45. So you plot those ordered pairs and then connect the dots, and you get this kind of curve going on. You see on the right. If I want to graph, like say, the square root of x minus 4, again, I would start with what makes that inside 0. So x minus 4, in terms of what makes that 0, would be when x is 4. So if x is 4, y would be y would be the square root of 4 minus 4, which is the square root of 0. If x is 5, then this would be the square root of 5 minus 4, which would be the square root of 1, or 1. If and you can pick some other ones and use your calculator to approximate. If you want some more exact numbers, here, if x is 8, the square root of 8 minus 4 would be the square root of 4, which is 2. And let's see, I think 13, it goes beyond the graph, but that would be the square root of 13 minus 4, so the square root of 9, which would be 3. So if I start with this first point 40, that'd be 1, 2, 3, 40 would be right here on the x-axis. 5, 1 would be right about there. 6, 7, 8, 2, I guess, would be about there. That's about as far as I can go with this graph. And then, connect the dots. And that's going to be the graph of the square root of x minus 4. Now, when it comes to solving radical equations, many times equations contain either radical expressions or rational exponents. For example, the square root of x equals 6. One strategy for solving a square root equation is to isolate the radical, if you need to isolate it, and then square each side of the equation. This technique is an example of the power rule for solving equations. And what I mean by power rule is that if you raise two equal quantities to the same power, the results are going to be equal quantities. That is, if x, y, and n are real numbers and you know x equals y, then x to the n is equal to y to the n for any exponent n. And specifically for what we're doing right now, if x equals y, then x squared equals y squared. So if both sides of an equation are raised to the same power, solutions of the new equation contain all the solutions of the original equation, but might also contain additional solutions. So after applying the power rule, the new equation can have solutions that do not satisfy the original equation, and these are called extraneous solutions. So unlike before, when it comes to lines, when it comes to square root functions, we really need to check our answers to make sure they are indeed correct answers. But sometimes even if you do everything correct, you may still end up with a wrong answer. And one last thing before we try some solving. For any non-negative real number, the square root of something squared is going to be that number. So for instance, the square root of 16 squared, well, square root of 16 is 4, so that's going to be 4 squared, which is 16. The square root of 36 is 6, so the square root of 36 squared is 6 squared, which is 36. So the square root of something squared is that something. So in other words, square roots and squares basically undo each other. Alright, so say I have this square root of x plus 1 equal to 5, and I want to solve for x. So the idea is, I'll square both sides, and the square root of x plus 1 squared is x plus 1. 5 squared is 25, and then if I subtract 1 from both sides, I end up with x equal to 24. And if I check that, if I do 24 plus 1, that is the square root of 25, which is, if I want to check this with Desmos, what I can do is say like y equal to the square root of x plus 1, and say y equals 5. And what I want to know is where these two graphs cross each other. And you can see that it crosses when the x value is 24, which was the answer that we found. If I have something like the square root of 2x minus 3 equal to 9, again, square both sides, so I'll have 2x minus 3 is equal to 9 squared, which is 81. Add 3 to both sides, so you have 2x is equal to 84. And then if you divide both sides by 2, you have x is equal to 42. So to check this, square root of 2x minus 3, so let's get rid of this stuff. The square root of 2x minus 3, and I'll say like y equal to, and let's say y equal to 9. Again, you may need to zoom out a bit, but there it is. It occurs when x is 42, which is the answer that we found. If I have the square root of 3x minus 2 equal to 4, again, if you square both sides, that becomes 3x minus 2 on the one side, and the other side is 4 squared, which is 16. Add 2 to both sides, so you have 3 times x is equal to 18. And then if you divide by 3, you have x is equal to 6. And if I check that, 3 times 6 minus 2 is square root of 18 minus 2, which is the square root of 16, which is 4, and that checks. If I use Desmos, I make it 3x minus 2, and y is equal to 4. And you can see that they intersect right there when the x value is 6, which was the answer that we found. Alright, finally, explain why it is immediately apparent that the square root of 8x minus 7 equals negative 3 has no real solution. Well, one reason is the square root of something is always greater than or equal to 0. So negative 3 is less than 0. So on the left side, you have something that's 0 or larger. The other side, you have something that's negative. there's no way those can be equal. So this has no real solution.